All right, so hopefully you've made an honest effort at this page at this point, and then you're just using this to try to check your work and make sense of it. So this is sort of an independent investigation activity, and of course you can ask me questions if you have them after you've listened to the video. So your job here was to try to make sense of this situation, and when we make sense of that situation, we're going to try to identify a couple of really important features of it. And so just to review the information here, we've got 3x plus 4y equals 108. We've got two blanks to fill in here. We're talking about a hot dog cart that sells two kinds of dogs. They sell a deluxe dog for $4 with 2 toppings and 2 sauces, and they sell a good dog for $3 with 2 sauces, which I think I'll highlight in a different color here. Okay, so something I'm noticing already is that good dog for $3, there's a 3 in the equation there, and deluxe dog for $4 is a 4 in the equation there, so that seems to be related. Then I've got this table and this graph that seem to represent the same thing, or at least that's what it says. So let's try to engage the questions. The table, graph, and equation don't quite live up to our exacting algebra standards. None of it is labeled. Add labels for the x and y axis in the graph and provide a key for the table in question, table and equation. What do x and y represent about the hot dog cart business? All right, so I'm going to go back to my small insight here regarding the deluxe dogs for $4 and that showing up as 4y there. And so that tells me that y represents, I think, deluxe dogs. And the reason I think that is that since deluxe dogs are $4 and the 4 shows up next to the y, the rate for y is 4 and the deluxe dogs rate is 4. And so I know that coefficients are rates and rates show up next to their variable, so I think that's how they're related. So I'm going to summarize that by saying y represents deluxe dogs. I can tell because 4y matches the price of $4. Okay, I need to identify x, and so I said good dogs are $3. There's a 3 next to the x, so I think x represents good dogs. And I can tell because 3x matches the price $3. Okay, and so I've made my key, I guess. I need to put x is number of good dogs, and y is number of deluxe dogs. Cool, and so that means that has to be true here as well. This is good dogs, and this is deluxe dogs. I'm just going to put that in there. If we need to label our axes here, and so I said x was good dogs. I'm going to write that here, good dogs, and y represents deluxe dogs. Whoops. Okay, I made some weird marks here. Let's get rid of those. Okay, good. The y-intercept occurs when x equals 0. That's maybe the most important thing about y-intercepts that you can know. Y-intercepts happen when x equals 0. What is the y-intercept for the relationship? So I need to find where x is 0, and that happens right here. There's x being 0, so the y-intercept is 27. So I'm going to write that as 0, 27. So the table has it as the entry 0, 27. In the graph, we've talked a lot about this. The y-intercept happens right there where the line crosses the y-axis. And in the equation, it's a lot less obvious. So let's look at this equation. We said that the y-intercept occurs when x is 0, so I'm going to execute that. So the y-intercept occurs when x is 0, so that means x is 0. So I can rewrite this as 3 times 0 plus 4y equals 108. And so because I know the y-intercept happens just when x is 0, I just made x 0. So let's look at what happens to that. So 3 times 0 is 0. So I just get 4y equals 108. And so 108, I'll divide by 4 in order to find my y value. And so my y-intercept there is 27, because 108 divided by 4 is 27. So it's kind of hidden in the equation. You have to use this idea that when x equals 0, you find the y-intercept. And so I plugged it in as 0, and then I solved for y. All right, let's keep working. Consider what the x-intercept means for the context by thinking about what x and y represent. Because the y-intercept occurs when x equals 0, the y-intercept represents what happens in a situation when what is represented by x has a value of 0. So I said before x represents good dogs. And that means that at the y-intercept, the hot dog cart operator sold no good dogs, because we said x was 0. And so he sold 0 good dogs. And I can kind of look at that in a couple of ways. Here, I can see he sold 0 good dogs, and so he must have sold 27 deluxe dogs. I can see that on the graph here, because this is where there is 0 good dogs being sold, and he sells 27 deluxe dogs there. So therefore, the y-intercept means that if he's only selling deluxe dogs, because he didn't sell any good dogs, then he sells 27 of them. So in this case, the y-intercept means you're just selling deluxe dogs and you get 27 of them. All right, the x-intercept occurs when y equals 0. So that's maybe the second most important thing that we need to notice about this page. The x-intercept, which may be a new idea to you, the x-intercept occurs when y equals 0. And so let's look at what that means. So just like the y-intercept was where the line crossed the y-axis, the x-intercept is going to be where the line crosses the x-axis. So there's a spot right there. Here's my x-axis, and the line is crossing it right here at that spot. And I can find the coordinates of that spot. It says it's where y is 0, and indeed that is 0 up or down from the origin. So there's my x-intercept. It happens where y is 0, and so my x-intercept in this case is 36, 0. How does it appear in each of these representations? Well, in the table, it was as the entry 36, 0, where y was 0. On the graph, we just said it's where the line hits the x-axis. That's why it's called the x-intercept. And now we're going to do something similar for the equation. So the x-intercept occurs when y equals 0, so I'm going to make y 0. So that's 4 times 0. I'll construct the rest of the equation around it. So all I did was, I know that the x-intercept happens when y is 0, so I'm going to change y to 0 and see what I get for x. Now I'm solving for x. So when I solve for x, I get 0 here, so I get 3x equals 108. I'm going to divide to solve it, and x equals 36. Okay, so you can consider what the x-intercept means for the context by thinking about what x and y represent. Because the x-intercept occurs when y equals 0, the x-intercept represents what happens in the situation when what is represented by y has a value of 0. Okay, so y represents, we said, deluxe dogs. And that means that the x-intercept, the hot dog cart operator, sold none of those. Because we're saying that y is 0, so that means he sold no deluxe dogs. Therefore, the x-intercept means that if he only sells good dogs, he sells 36 of them. And so the x-intercept in this case means, well, look at the x-axis, it means good dogs. He's selling none of the other kind, and if he sells none of the other kind, he's going to sell a total of 36 good dogs.